I'm Robert from Dresden University of Technology, and today we have a little guideline on how to clean your optical elements without destroying them. Of today is, of course, to know to clean the optical elements with the correct tools. In your lab, you will have different kind of dust or dirt materials that will put on some spots onto your mirrors, onto your lenses, as shown over here. And those dust particles, then the laser radiation get absorbed on those and will generate a slightly burning or damaging inside of the coatings that you're having, which then leads to a thermal burning of your system and of your optical element, which can't be used as this one anymore. And therefore, you need to keep them clean and prevent that's happening. Otherwise, you have to replace all the optics multiple times, as well as they have some issues in your process, and you might destroy samples while production. So when we're talking about cleaning optical elements, we just have to show or have to see how do I grab the optics best. Well, in the best case, you don't grab them at all. But if you have to, please wear gloves, even if they're out of rubber or if they're out of cloth. Just make sure that they are lint free. So if you have your optical element here, general rule of thumb is first of all, do not touch the optical surfaces, right? So the top surface where the coating is, even with your gloves, even with rubber or cloth, please do not touch the optical surfaces on an optic. If you have to grab them, you have to grab it on the lateral surface of the element to prevent any kind of damaging of the system. Furthermore, you can use tweezers out of polymer in order to grab them, but you have to be extra caution if you because there is the possibility that you somehow lose the grip and make a scratch onto the coatings, and with this one you destroy this even further. So you really have to make sure to have a fine, good grip on it in order to be safe. When it comes to cleaning of optical elements, there are different kind of cleaning agents that you can take, either ethanol, isopropanol, acetone, DI water, soapy water, compressed air, or even nitrogen. We will have here some steps for cleaning an optical element, and we will start always with the dry cleaning with compressed air or with nitrogen. This is the one that is has the least, let's say, negative influence onto the optics or coatings. It's the most sensible one. And you only have to make sure that the water, that the air that you're being used is water-free and oil-free. So you got to use some filter systems in front. Furthermore, you can use as well deionized compressed air or deionized nitrogen in order to prevent any more dust accumulation so far. Furthermore, as you all know, there's also the possibility to have compressed air in cans, and there's always important to keep the cans horizontal and not moving in a vertical way, because with this one, if you make kind of an inclination, as even shown on the cans, the propellant can get loose out of it, and that will even further make your optical elements dirty. So therefore, always make sure cans always held horizontally, and just by pushing then maybe the hose which is attached to it if to reach the optical element. So the second step is if the dry cleaning didn't work, then we have, of course, as well the wet cleaning. Therefore, we have to make suitable cleaning agents as well as tissues that are lint-free. First of all, when you have a wet cleaning, never clean optics with a tissue without any fluid, because that will generate any kind of scratches onto the coatings and will lead to the destruction of the coatings and the optical elements. So never use any kind of tissue without any kind of cleaning fluid. As a cleaning fluid, as I already said, you can use acetone and isopropanol. I cannot recommend this for doing that because they vapor with residuals on top. And furthermore, they vapor pretty swift. So this isopropanol or acetone will penetrate through your coatings and will expand during the vaporization, which then leads to a detachment of those porous coatings. It's better or best to use ethanol that is water-free, and of course to use some kind of cleaning tissues, which I already mentioned, that are lint-free. So now we're coming to the procedure of wet cleaning. So first of all, what you have to do, you have to set your tissue at the edge of the optical element, as you can see over here. And next, you wet the tissue with your water-free ethanol, some certain drops, and then you move or you pull the tissue slowly over the optics so that a homogeneous film forms behind the paper. So we know that the film evaporates then shortly behind the cloth, and this is largely determined about the amount of liquid that are being used. And here is where your experience comes in. You will never get it on the first try, and if you start cleaning optics, you will have certainly some kind of challenges in that case. So you need to make or gain more experience. So maybe first of all, try with different optics that are already been damaged or are not in use anymore to train yourself. So you need a lot of training to know how much liquid do you use, how fast you pull, and if there's any kind of residual on the edge or not. So this is something that you have to train by a lot. And of course, when it comes to wet cleaning, there's also the possibility to have ultrasonic cleaning because there the removal of particles and residuals using an ultrasonic bath is being used mostly when you have any kind of glasses, for example, in this case. But the combination of ultrasonic wave and cleaning agents leads more to a destruction of an optical coating when we talk about optics. So this is basically not recommended to doing that. For glasses, it's fine, but for optical elements, such as for laser structures, is not recommended to use it. Otherwise, you will destroy the coatings. And with this one, I would like to thank you for your attention for this short educational video, and we see you in the next one.